Owls have always held a special spot of interest for people, both birders and non-birders alike. As they should, this group of birds can be elusive, secretive, adding to their allure. Owls have evolved so many unique adaptations to suit their lifestyle. The need to be able to navigate in almost pitch black darkness, to hunt in darkness, and to catch enough prey to survive, but also to provide enough for their young. To successfully hunt mice, small mammals, and other prey, they must be able to locate them in a field, forest, or even under a foot of snow. They must be able to pinpoint the exact location and then pounce, without their intended prey knowing of the impending ambush. While this may sound like a simple task, it's not, and owls have evolved a handful of adaptations to allow them to survive and thrive under this lifestyle. So, let's explore the world of owl adaptations. While owls are predators, they aren't immune to becoming prey themselves, especially if they are asleep and vulnerable to predation during the daylight hours. Especially when you consider it being a time when most predatory animals are active, like hawks, for example. To help keep themselves safe during this time, owls have evolved some of the most amazing cryptically patterned plumage. Mottled patterns of whites, grays, browns, and blacks along their feathers help them look nearly identical to the bark of many trees, to the point where they nearly disappear when they are perched against a tree's trunk. You can really get the feel of this amazing camouflage when you look at the back of species such as great horned owl, the screech owls, or a great gray owl. Even the diurnal snowy owl blends perfectly with its Arctic home. Its clean white plumage with varying amounts of black streaking helps it blend into the snow and rocky ground it may be perched on. Barn owls have a light brown coloring on their back, which blends perfectly in their grassland and field hunting grounds. Various species are different colors depending on their preferred habitat. Their ability to blend into their environment is truly amazing. Several species also have special adaptations to help break up their body shape as a bonus. Look at the top of the head of several different owl species, and you'll notice two small clumps of feathers there, looking similar to them having ears. About 50 species of owl are known to have these ear tufts, which are not actually ears, but clumps of small feathers that can be held up or laid flat against their head. While they don't aid in hearing, instead they serve several other different purposes. One being that these tufts help break up the owl's silhouette and allow them to blend into their surroundings even more, looking similar to branches or twigs. On top of that, these feather tufts can be raised or lowered, making them a way to communicate to other owls, to help them make themselves look bigger, being a bigger threat to other owls or potential predators. To communicate with other owls, whether that is to communicate to a potential rival, to let them know that this territory is already occupied, or courtship with a potential mate. Many owls also have another way to communicate. That comes in the shape of a white patch of feathers on their throat, right below their bills, which is often hidden until they need it. This group of white feathers is called the gular pouch. While normally hidden, when hooting or calling, this pouch is in a way inflated and becomes quite visible, especially when the owl itself is typically a darker shade of gray or brown. In the dark, this contrast of color really stands out and is used as another method to communicate with other nearby owls. Camouflage and being able to blend into their surroundings isn't the only key to an owl's success. To survive, they must be able to successfully hunt at night, in near total darkness, in some cases. One way to successfully catch prey at night is to have an incredible eyesight. One look at an owl, and you will notice their eyes are particularly large for their head size, especially if you compare them to other birds, like hawks or eagles, which themselves have incredible eyesight. If our eyes were proportionally the same as an owl's, Ours would be about the size of a softball. Another comparison of owl's eyes to ours is that an owl's eyes make up about 5% of the owl's body weight, while ours are about 0.0003% of our body weight. Fun fact, since owls' eyes are so big, if you peeked into the ears of some species, you would actually be able to see the back of their eyes. Another cool thing about an owl's eye is that generally, if you look at its color, you can tell what time of day that species is going to be most active. Though, again, this is not true in all cases. If their eyes are brown, like barred owl or barn owls, they'll most likely be nocturnal or active at night. If they are yellow or orange, they're more likely to be diurnal, active during the day, or crepuscular, most active at dawn or dusk. It is believed that by having dark eyes as a nocturnal bird, that it helps with their camouflage and being able to go unnoticed by both predators and prey. But an owl's eyes differ from many birds in even the most simple ways, its shape. While most eyes are round like a ball, owls' eyes are more of a tube shape, and inside these eyes are two types of photoreceptors, rods and cones. Rods are extremely sensitive and are important for seeing in low light conditions, while cones need much more light to be useful and are responsible for being able to see colors. Owls have a rod to cone ratio of about 30 to 1, while humans have only about 20 rods for every cone. Most diurnal bird species, meaning those active during the day, like hawks, eagles, and falcons, have two fovea, which are areas of the retina that are associated with high photoreceptor density. Owls, on the other hand, only have one fovea, with a high concentration of rods. This combination leads them to having excellent vision in extremely low conditions, but at the expense of having great color vision. It is believed that some owl species can be up to 100 times more sensitive to low light conditions than us. Their eyes are also forward facing, perfect for tracking movement and successfully catching prey. Where the field of view overlaps on both eyes, they have binocular vision. Having a large binocular vision field of view can be seen in many predatory species. This perception gives them a three-dimensional view of their world, allowing them to better gauge distance and depth. This field of view for owls is about 110 degrees, with 70 of that being binocular vision. To have room for this great vision, though, owls need to have very large eyes. This leads to several other problems, though. To keep these eyes in the correct spot and position in the skull, they are held in place by bony structures called sclerotic rings. These sclerotic rings, though, don't allow their eyes any room to move. Their eyes are, for all purposes, locked into their skulls. To look left or right, up or down, they literally need to move their head in that direction. This leads to an issue with them possibly having a very narrow field of view, relying completely on how far in each direction an owl would be able to turn its head. Owls, again, have come up with an amazing way to fix this issue. So, how do they get around this limited field of view issue? And that is with a special skeletal structure in their neck. While us humans have 7 neck bones, owls have 14. The extra bones allow them a greater range of motion, up to 270 degrees each way. Humans, for example, can only turn our head about 90 degrees each way. On top of that, the neck bones at the base of their neck have another special adaptation. If we somehow were able to turn our heads to that degree, we would have a big issue. Our bones would pinch blood vessels and block blood from from getting to and from our brain. So, how do owls get around this issue? One way is that their carotid arteries, instead of being on the side of their neck like us, are actually located just in front of the spine. By being there, they experience much less twisting and stretching whenever they turn their head. On top of this, there is extra space for the arteries. The neck bones have larger cavities in them to let the arteries pass through. While humans, this area is just big enough for the arteries to go through. In owls, this cavity is about 10 times bigger than the space that is needed. In addition, in owls, this space seems to also be filled with an air sac to further protect this vulnerable blood supply. Combined, these features allow a proper blood supply to their head, even when it's turned 270 degrees one way without causing damage. Another recent discovery is that the carotid artery on owls have wide segments in them, just under the base of their skull. Researchers have found that these segments could dilate and fill with blood, creating a form of reservoir for the blood to avoid disruptions in its flow when they turn their heads. Another important sense that owls have is their hearing. Birds, unlike most other animals, don't have external ears. Instead, they have what is more like holes or slits in the side of their head. Each slit that makes up the opening of their ears is a flap of skin, which is called the ear conch, which then opens up into a large ear canal. The flap over the ear can open or close by using the muscles that are located under the ring of feathers that surround their face. To help enhance their hearing even more, the feathers of an owl's face form a facial disc. These feathers around their eyes act as a bit of a satellite dish, funneling sounds towards these ear openings. Even their bill is in a form that helps direct sound to their ears. By being short and pointed downwards, it actually increases the surface area where sound waves get collected by their facial disc. While some owl species have these ear openings symmetrically on their head, like our ears are directly across from each other, many owl species have asymmetrically placed ears. This appears as one ear being higher up on one side of the owl's head than the other. This unique feature can be easily seen if you look at the skull of several owl species that have these asymmetrically placed ears. There is actually a big benefit for them to have this odd ear placement. This ear placement actually helps the owl judge to a greater extent of where a sound is coming from, especially on a vertical axis. For example, if an owl hears a possible prey item, like a mouse, even if it's under snow, the sound would reach one ear before the other. If an owl continues to turn its head until the sound hits both ears at the same time, it would have pinpointed the exact location of where that sound was coming from. This amazing adaptation can greatly increase its success rate of catching its intended target. This can really be seen in nocturnal species like the boreal owl and barn owl. To properly translate how the sound is received and processed where it is coming from by creating a mental image, owls' brains have a complex medulla, which is the part of the brain that is associated with hearing. For example, a barn owl's medulla is believed to have, at minimum, 95,000 neurons, which is about 3 times as many as a crow does. That really demonstrates how important this sense is to owls and how they survive. If you look at what animals an owl typically prey on, you may notice that many have large ears, mice and rabbits being great examples of this. Nocturnal mammals also rely on a heightened sense of hearing to avoid predators while they're out and about at night. So for an owl to successfully catch these animals, They have to be able to hunt while not alerting these potential preys to their presence. And that leads to one of the adaptations that owls are most famous for, their silent flight. Owls, proportionately, have quite large wings for their bodies. They seem to fly almost effortlessly thanks to that and their light bodies, leading to less wind resistance going over their wings and giving them the ability to fly at a lot slower pace than many other bird species would be able to. Their flight feathers are especially adapted to allow for this silent flight, and each have a fringe along the outer edge called combs. And on the surface and trailing edge is a velvety fur-like texture to them. The leading fringe on these feathers soften the flow of air as it goes over the wings as the owl flies, breaking up the air that makes sounds as it goes over the feathers. The soft fur-like texture that covers the feathers helps to absorb and disrupt noise from the air and that the feathers make as they move against each other. There is quite the amount of surface area of contact with each feather and the ones on either side of it. That friction between them would normally create quite the amount of noise if it wasn't for these adaptations. Think about how noisy most birds are in flight when they fly overhead or nearby. Even little finches can make quite the noise when they fly over you. So, what about owl species that primarily prey on species that don't have good hearing, like fish or insects, though? Studies have been done on the connection between an owl's wing combs compared to what their primary diet looks like. Fish and insect-eating owls were found to have narrow combs, which means that these owls have less noise-canceling qualities to their feathers, and wouldn't be as silent as other mammal-eating owls. You don't really need to be as quiet when you're hunting fish that are underwater, or hunting insects that really don't have good hearing. Some species even have little to no comb structures on their flight feathers, like the burrowing owl or the tawny fish owl, for example. Also, when you look at the noise-canceling structures on owl feathers, you'll notice that many diurnal species, or again those active during the day, like snowy owls, also have much smaller comb size on their feathers than nocturnal owl species. Another little adaptation I want to highlight is called a pectinate claw, which is present only in barn owls. This specific tool is usually located on the middle longest talon. This adaptation isn't just found on barn owls, though. It can be found on species such as herons, egrets, bitterns, and nightjars. This claw is special in that it has ridges on the inner edge that look very similar to a comb. These ridges are believed to help with preening and straightening facial feathers. This is especially important to barn owls as their facial disc and feathering on it help direct sound to their ears for hunting. And studies have found that they have the ability to hunt in almost complete darkness, even more so than many owl species. Overall, owls are a perfect example of some of the amazing, unique adaptations that can be found in the world of birds, of how they survive and support their lifestyle of hunting at night. I hope you learned a few things about this amazing group of birds and continue learning more about this amazing group of species. If you did enjoy this episode, please feel free to share it. And always, you can follow me on Instagram and Facebook at Kayla Fisk Birds. Thanks for listening, all you lovely bird nerds, and have a great day.